pancreas is a combined endocrine-exocrine organ. It sits in the first bend of the duodenum. It is a mixed endocrine-exocrine gland. The exocrine products are the digestive enzymes. The endocrine products are the insulin, glucagon, somatostatin. The endocrine hormones are produced by cells called the islets of Langerhans. And these cells, I have a picture of it, yeah, they're within the pancreas. There are little islands, or they call them islets, pancreatic islets, that contain special cells, alpha, beta, delta cells. And those cells, the alpha cells produce glucagon, the beta cells produce insulin, the delta cells produce somatostatin. And you can see down here, these are the acinar cells. The acinar cells are the ones that produce the digestive enzymes. So the acinar secretions come out through the main pancreatic and accessory pancreatic ducts into the duodenum. Where are we here? Okay, here's a table that summarizes the different cell types and what they produce. Glucagon is an antagonist of insulin. Insulin is secreted, as I mentioned before, when you eat a nice carbohydrate meal. As your blood glucose levels go up, insulin is released. It acts on the tissues in the body, acts primarily on liver, bone, and muscle to take up glucose. Actually inserts a glucose receptor. I said insulin. I said liver, bone. It doesn't. I don't think it acts on bone. Liver and muscle for sure. But at any rate, it acts on specific tissues to increase the uptake of glucose. The cells, insulin brings about the production of specific glucose transporters into the cell membrane, and it then attaches the glucose and transports the glucose into the cell. If insulin is not available, then the glucose levels become quite high, and that is called diabetes mellitus, which can lead to a tremendous number of problems. As I mentioned before, diabetes is becoming more and more prevalent as American society gets older and older. Glucagon, on the other hand, stimulates the liver to break down glycogen and increase the production of glucose. So when the glucose levels drop, glucagon is released, and it acts on the kidney, on the liver, to break down glycogen and increase the glucose blood levels. So these two work opposite of each other.
So it's hypoglycemia?
So glucagon, yeah, is released in hypoglycemia. And somatostatin is inhibits growth hormone. It is secreted during digestion, and it slows the rate of absorption of many of your digestive nutrients. But don't worry so much about somatostatin. Insulin and glucagon are the two main hormones. And when you get into physiology, you'll get into great detail about diabetes mellitus. All right, the ovaries. The ovaries and gonads, male and female, both begin in the pelvic cavity. Depending on the chromosomal makeup of the individual, if it's XX, it's going to be a female. If it's XY, it is going to be a male. The ovaries, if a female, reside up in the pelvic cavity. They are not very large structures. They're sort of bigger than a walnut, I guess. They're suspended by ovarian ligaments and attached to the uterus. They produce the ova for reproduction. Each month the ovaries release one ova. We'll go into greater detail about these on Monday. But they, when they release an ova, it is released into the pelvic cavity. And these finger-like structures you see here, these are called fimbria. These are not connected to the ovary, but as the ova is released, the ova is swept up into the infundibulum of the fallopian tubes. And then if fertilization is going to occur, it'll occur up here. Once fertilized, the ova makes its way down into the uterus where it is implanted, and the pregnancy goes forward. The ovaries produce two hormones, estrogen and progesterone. When a woman is first conceived in utero, she has about 6 to 7 million ova in her ovaries. At birth, that number is reduced down to a little over 1 million. And by the time she achieves puberty, she's down to around 400,000 ova. And then, as you know, about the age of 45 to 50, she goes through what is called menopause and will no longer ovulate. Why there is such a reduction in the number of the ova, I don't know. Obviously, in her lifetime, though, she's never going to ovulate 400,000 ova. But the ovaries are under the control of FSH, follicle stimulating hormone, which leads to the maturation of the ova. And the ova start out as what is called a primary follicle. Under the influence of follicle stimulating hormone, several of the primary follicles will begin to develop. But most cases, only one of them will go on to develop into what is called a vesicular or Graafian follicle, which you see right here. Here is the ova right here, and it is attached to the wall of the ovum. And in the middle here is what is called follicular liquor, which contains progesterone and estrogen. As that follicle, and this takes about a 28-day cycle, as that follicle evolves or matures, it becomes what is called a mature Graafian follicle, and under the influence of LH, luteinizing hormone, it is released into the pelvic cavity. If fertilization occurs, this residual portion here will continue as what is called the corpus luteum of pregnancy. If fertilization does not occur, then this atrophies and becomes scar tissue called the corpus albicans. All the time that the ovary is going through this cycle, the uterine wall is being prepared for implantation of the fertilized ova. And so the female has two cycles, a uterine cycle and an ovarian cycle. And I suppose many of them have bicycles too.
It's cute. No, it's cute. I got that.
Anyway, women are very complicated. And your menstrual cycle, your uterine cycle, and ovarian cycle is very complex. I leave this to the last lecture in physiology because it's quite difficult to understand. But at any rate, ovulation, the development of the ovary, the development of the female sexual characteristics is under the influence of estrogen and progesterone. FSH and LH certainly are instrumental in the development of the ova as well as preparation of the uterus. The uterus, as far as preparation for implantation, is primarily under the control of progesterone. And so the female cycle is referred to as the menstrual cycle. The first 5 to 7 days is a sloughing off of the uterine wall called menses, and then after that the uterine wall begins to grow and sort of laying down the turf for the implantation of the fertilized ova. If it doesn't occur, then menses occurs. This entire wall sloughs off, and she begins to cycle anew. Now the male gonads are referred to as testes. As I mentioned, they start in the same location as the female. The male obviously has two chromosomes, X and Y, and in the fetus is XY, then the testes begin to develop. They begin secreting testosterone in utero. And whereas in the female, estrogen and progesterone are not really produced in high concentrations until they go through puberty. Female sexual development is controlled to a large extent by the adrenal androgens. And then once she goes through puberty, progesterone and estrogen levels increase significantly. Whereas in males, testosterone secretion occurs all throughout life. Males do not go through menopause the same as females do. They go through what's called an andropause. They will have a reduction in testosterone levels, and but they will continue to produce sperm all throughout their life. Wasn't it Tony Randall that gave birth to a child when he was 84 years old? Or he didn't give birth, but he fathered a child. Put it that way. Why you would want to have a child at 84 years of age, I have no idea.
I don't think he meant to.
Huh?
I don't think he meant to.
Well, he shouldn't have been messing around.
That's right.